Hello everyone. So in this lecture I will be explaining torque equation of three-phase induction motor. So this is one of the important topic in electrical machine. So let's start. Torque in a three-phase induction motor determined by three key factors. So that factors are firstly rotor current, that magnitude of rotor current, magnitude of rotor current. Secondly, the flux which is interact with the rotor of three-phase induction motor. Secondly, that flux which interact with the rotor of the three-phase induction motor and is responsible for producing EMF in the rotor part of induction motor. Then third one is power factor. That power factor of the rotor of a three-phase induction motor. So these three are magnitude of that rotor current, then flux, then the power factor. So these are the three terms which is responsible, we can say that very important factors of three-phase EMF equation of three-phase induction motor. So by integrating these factors, we derive the torque equation. We can write. So by integrating these factors, we can derive the torque equation. So that T equal to that T proportional to phi I2 cos theta 2. So where T is the torque produced by the induction motor. So this T is the torque produced by the induction motor. Then phi is the flux for producing EMF. So this phi is the flux. This is the flux responsible for producing induced EMF. Induced EMF. Then I2 is the, so this I2 is the rotor current. This is rotor current. I2 is the rotor current, and cos phi 2 is the power factor of the rotor circuit. This cos phi 2 cos theta 2 is the power factor. This is the power factor of the rotor circuit, and the flux phi produced by the stator is proportional to the EMF E1. So, and the flux phi produced by the stator is proportional to stator EMF E1. So that is phi proportional to E1. Now we know that the transformation ratio that is K is defined as the ratio of secondary voltage or that is the rotor voltage to primary voltage. Primary voltage means stator voltage. So we can write K is equal to E2 by E1, or we can write K is equal to E2 by phi. As we know phi is equal to E1, so we can write E2 by phi. or we can write E2 is equal to phi. So phi. Now the rotor current, rotor current means that is I2. I2 is defined as the ratio of rotor induced EMF rotor induced EMF under running condition under running condition is SE2 to total impedance, E2 to total impedance Z2 of rotor side. So that is I2 is equal to SE2 by Z2. So this now, and total impedance Z2 on rotor side is given by Z2 is equal to root over R2 square plus SX2 whole square. So this we can write from the fundamental equation. Now this putting this value in the previous equation, we can write I2 is equal to SE2 by, in place of Z2 we can write R2 square plus SX2 whole square. So S is the sleep of induction motor. So where S is the sleep of induction motor. Till now we have find out that current I2. So this rotor current, till now we have find the expression for, or find the value of I2. Now next we will find out the power factors. So that is cos phi 2. So let's understand how we can derive this cos theta 2. We know that power factor is defined as the ratio of impedance, so resistance to that of impedance, that is resistance to that of impedance. So the power factor of the rotor circuit is, so that power factor we can write cos theta 2 is equal to R2 by Z2. So that we can write R2 what is the Z? So that is root over R2 square plus SX2 whole square. So this is cos phi 2, or we can say this is the power factor. So till now we find out that rotor current I2, then the power factor cos phi 2 and flux. So now put these three value in the torque equation. We can write, so torque equation was T proportional to okay, before putting, let's recall, like we have calculated that phi 2, so that phi is, so this is the one term, that, so that we have calculated phi is E2. Then we have calculated I2, so that I2 is this S2, so SE2 by root over R square plus SX2 whole square, and lastly we have calculated that cos theta 2, so that is R2 by root over r2 square plus sx2 whole square. Now if we put these three value in the torque equation, we can write, so initial torque equation was T proportional to phi I2 cos theta 2. Now if we put all these three values here, so we can write T proportional to that phi is E2, then I2 is S E2 by root over r2 square plus sx2 whole square into cos theta 2 is equal to r2 by root over r2 square plus sx2 whole square. So these are the three values. Now combining these three terms, we will get T. So from this, what we can write, T proportional to S E2 square, so that is T proportional to S E2 square, so that into R2 by R2 square plus sx2 whole square. So this we can write this. We can write this. Now removing the proportionality constant, we can write, by removing that proportionality constant, we can write T is equal to ks E2 square R2 by R2 square plus sx2 whole square. So this constant k equal to, this constant k is equal to 3 by 2 pi ns. So where ns is the synchronous speed, where ns is the synchronous speed, in rps. So ns, this ns is equal to ns by 60. So finally the equation became, so we can write that equation T is equal to S E2 square into R2 by R2 square plus sx2 whole square into 3 by 2 pi ns Newton meter. So this is the torque equation of three-phase induction motor. Now how this constant k is derived in the equation? This term k is derived in the equation. So in the three-phase induction motor, that copper loss occur in the rotor. Copper loss occurs in the rotor. These rotor copper loss are expressed as, the copper loss is expressed as, that is Pc is equal to 3 I2 square r square. We know that rotor current I2 is equal to SE2 by root over R2 square plus sx2 whole square. So substituting this value of I2 in the rotor copper loss Pc, we can write Pc is equal to 3 R2 into SE2 by root over R2 square plus sx2 whole square, this square. So on simplifying this Pc, we can write Pc is equal to 3 R2 s square E2 square by R2 square plus sx2 whole square. Now we can write this Pc, we can write P2 it's to Pc it's to pm. So this is equal to 1 is to s is to 1 minus s. So where P2 P2 is the rotor input. So this is rotor input. P2 is the rotor input. Then PC is the rotor copper loss. So this is rotor copper loss. PM is the mechanical power developed. Mechanical power developed. Mechanical power developed. Mechanical power developed. So we can write PC by PM is equal to S by 1 minus S, or PM is equal to 1 minus S into PC by S. Now substituting the value of PC from the previous derivation. So from this, if we put this value of PC in this equation, we can write PM is equal to 1 by S into 1 minus S 3 R2 S square E2 square by R2 square plus S X2 whole square. So on simplifying, we can write, after simplification, we can write PM is equal to 1 minus S 3 R2 S E2 square by R2 square plus S X2 whole square. So the mechanical power developed, the mechanical power developed, that is PM, is equal to T omega. So that is T omega. So we know that omega is equal to 2 pi n by 60, or we can write PM is equal to T into 2 pi n by 60. Now substituting this value of PM in this equation, we can write 1 by S into 1 minus S into 3 R2 S square E2 square by R2 square plus S X2 whole square is equal to T into 2 pi n by 60, or we can write T is equal to 1 by S into 1 minus S 3 R2 S square E2 square by R2 square plus S X2 whole square into 60 by 2 pi n. And now we know that n is equal to ns into 1 minus S. Now substituting this value of rotor speed, this value of n is the rotor speed, so this rotor speed, that is ns into 1 minus S, in the above equation, here in this equation we can write T is equal to, T is equal to 1 by S into 1 minus S 3 R2 S square E2 square by R2 square plus S X2 whole square into 60 by 2 pi ns into 1 minus S. Just replace this n into ns into 1 minus S. So ns is speed in revolution per minute. So this ns is revolution per minute, or that is RPM, revolution per minute, and ns is speed in revolution in per second, and ns small ns is revolution per second, so that is rps, and that relation between these two is equal to ns by 60. Ns by 60 is equal to ns. Now substituting this value of ns, substituting the value of ns in the above equation and simplifying, we will get the torque equation. The torque equation T is equal to S E2 square R2, S E2 square R2 by R2 square plus S x2 whole square into 3 by 2 pi ns, or we can write T is equal to K S E2 square into R2 by R2 square plus S x2 whole square. Now comparing both the equations by comparing both the equations, by comparing both the equations, we get constant k is equal to 3 by 2 pi ns. Okay, this is the complete derivation of torque equation of three-phase induction motor, and the derivation of, and the explanation, or you can say the derivation of constant term, that k. Thank you everyone. If you like my videos, kindly subscribe,